Okay, here we are given the graph of the original function f, and we'll try to sketch its derivative, right? So here is the deal. We should be looking for the easy slope first. And of course, the easiest is when we have a horizontal tangent line. And of course, right here, we do have a horizontal tangent line. So that means I will have to go down, and that will give me 0 for the f prime, all right? So again, this is going to be my f prime graph. And now I will just start from the left-hand side, and I'll pick the next easiest number to look for, which is slope equal to 1, and that's 45 degrees. So if you look at maybe right here or so, and again, we can only estimate and all that. So if you look at this like this, right here, right? The slope is about positive 1, namely 45 degrees. So I will just go down, and let's say here is my 1. So I will have to just remember 1, and that's the f prime value. And then you can just continue. Well, if you move away right here, this right here, it's actually going to be bigger slope than that, right? It's steeper, it's going upward. So this right here, when you go down, you should have a higher y value. So maybe like this, right? And then we'll continue. So let's say if we are right here, this right here, in fact, even having a bigger slope than that, so I will have actually go down, but I will have to have a bigger y value like this. And perhaps we can do another one. This right here, in fact, is actually a much higher slope as well, much bigger slope, so I will actually put down some of this. Not necessarily like straight line, but maybe like curve and all that stuff, right? Now, go to the other side. Well, let's look for 45 degrees this way, so we get the slope -1, which is about right here, maybe, I would say, right, like this, and now, okay. So from here, I will just trace down, and we will have a -1 slope like this. And then continue. Right here, this right here, it seems like this right here is actually more down, right? It goes down more. So when I go down, I will have a lower y value. So that's what I have. However, though, I noticed that this right here is what we call the point of inflection, because as you can see, you have a concave down situation and then a concave up situation, right? So in fact, this right here is going to be the smallest slope, right? So it's going to be down there. Because after this point, if you move here, if you draw a little tangent segment, you can see that this is flatter than that. So when you trace down, it has to have a higher y value than the earlier point. This right here, when you trace down, it has to have a higher y value than the point that we had earlier. And likewise, if you're just moving to this point, for example, this right here, again, it's negative, but this is flatter than that. So when you go down, it has to go below the x-axis, but it has to be having a higher y value like this. And in fact, once you are right here, the slope is almost like 0. So in fact, you go down, and again, it has to be below 0, below the x-axis, so like that. So I would say the graph will look like something like this. I will just kind of graph this, like a curve actually, and then like that. Right? So, somewhat like this, and again, we'll just estimate as long as you get the right shape, that will be correct. And that's it.